All right, go ahead, Bruce.
Okay, welcome everyone. And it's good to see some familiar faces and names from space classes. I'm Bruce, and I'm a teacher with Create and Learn with the space programs, NASA SPEM Camp, and so on. We have a very special evening, afternoon in store for you today. A couple of amazing, one of her most exciting contributions is collecting measurements of the SN 2023 IXF supernova. I hope I got that right. That appeared last year in the Pinwheel Galaxy. So yeah, looking forward to hearing a little bit more about that. I believe which was covered quite a lot in the media on TV there in California. Very, very impressive. And when Sophie's not looking up in the stars and discovering things up there, she likes playing volleyball, painting, music, and reading. So Sophie will be speaking second. Our first guest speaker is Heather Hewitt. And Heather Hewitt's a fourth-year PhD candidate at Arizona State University, a great, great university, especially for space-related matters. And Heather focuses on astronomy education and exoplanet research. And I was able to learn quite a lot from her, learning about her programs. And we had a very, very interesting session. So thanks again, Heather, for giving me that tutorial. Heather works closely, very closely with NASA's citizen science team, Exoplanet Watch, and she teaches students online to use all the tools provided by Exoplanet Watch so they can learn about things like hot Jupiters, which we'll learn about a little bit today. And Heather has a passion for making astronomy accessible and fun. And she uses citizen science as a tool to bring interesting and authentic real research full of data experiences to students all over. So today she'll introduce us to some fun citizen science programs like Exoplanet Watch and DYI Planet Search, where you can help discover new exoplanets. So yeah, welcome to our wonderful speakers. And thanks for everyone for coming to the meeting from all over the world. And I'll turn it over to you, Heather.
Sure, let me share my screen really quickly. All right, can everyone see that okay?
Yes.
Awesome. Okay, so thank you, Bruce, for the introduction. So as Bruce said, I do a lot of astronomy education research. So I do research into how to best teach astronomy and how to get more people involved in astronomy. So a big tool that I use is called citizen science, where anyone can be a scientist. And that's what I'll be talking about a bit today. So I'll first go over what is citizen science and what can it look like. And then I'll talk about the Zooniverse because it's a great example of what citizen science looks like at its best. And then I'll finish up talking about Exoplanet Watch. And as Bruce said, I work very closely with that team, and citizen scientists collect data on exoplanets with Exoplanet Watch. So to start, what is citizen science? I would love to hear if any of you know what citizen science is, or if you have any idea of what citizen science is, to go ahead and put it in the chat, and let's see if we have any ideas of what that might be. So it looks like it might be a new topic. That's great. We get to learn something new today. Community science, together science. Yep, these are all great guesses. So the definition that I have for you today is that citizen science allows for anyone to help contribute to real scientific research by collecting or analyzing data. And that doesn't just have to be in astronomy, it can be in any science at all. But what that means is that anybody and everybody, no matter their background, can turn their curiosities and their passions about the world and about our universe into real scientific impact. And so you can really play a role in doing scientific research. And it's great because both professional scientists and citizen scientists get to benefit from citizen science. So we each get a lot from the collaboration. But why do we need citizen science? The simple answer is that there's too much data, especially with all of the technology that we have access to. As professional scientists, we're able to collect a ton of data. And this data can take the form of telescope observations, images, or samples, depending on what type of science you're doing or what project you're working on. And in fact, we're able to collect so much data that we don't even know what to do with it all. So if you look at this graph over here, this orange line is going to represent how much data we can collect. And you can see that's a whole lot right there. But this blue line is the data that we're actually able to look at. And so you can see there's this huge gap between the data that we can actually look at and the data that we can collect. So there's all this data that we're collecting that we don't have a chance to look at. And most of that is just due to time constraints. We only have so many hours in the day to look through data. So there's a couple of different ways that we can address this because we need a solution. And some people mentioned AI, and that's a really great tool to use, or computer programming. Machines and computers can definitely help us a lot. But the thing about machines is that they're not very good at performing tasks that they're not trained to do, right? We have to train the computers to do everything that we want them to do. And so that's where all of you and other citizen scientists come in, because humans are actually better at computers at recognizing patterns. And the other thing we're better at is feeling surprised. And I know that that might sound a little bit silly just to feel surprised, but being able to feel surprised is really important when you're looking through a lot of data, because when you see something that you're not expecting and you're surprised, that's a good sign that maybe you should look a little bit more into it and maybe there's something really cool there. And computers just don't have that ability. So a lot of times it's better to have real humans looking at the data rather than computers. Although computers and AI, ChatGPT, as all of you mentioned, that certainly helps a lot. So in order to kind of introduce this idea of citizen science, I wanted to tell a story. And our story starts with a graduate student, and he was told to look through thousands and thousands and thousands of images of galaxies to determine what shape they are. So he was looking at images like these, and he basically had to sort through them and categorize them based on their shape. So, he might have looked at this and said, this is probably elliptical, and this is probably spiral, and so on and so forth. But this grad student had, again, hundreds of thousands of images that he was looking at. And so after working for 12 hours a day for an entire month, he realized that he had barely made a dent in the data. He still had hundreds of thousands of images to look through. So after working for an entire month, he was very frustrated and he realized, you know what? I need to figure out how long this is all going to take me. So that's what he did. He calculated how long it would take him to look through these hundreds of thousands of images. And he realized that if he worked for 24 hours a day, 7 days a week, it would still take him 3 years to look through all of these images. And he realized this is just not realistic and he doesn't have the time for it. And so he knew he needed some other solution to look through all of this data. And that's when, instead of finishing all that data by himself, he decided to turn to the public and to citizen scientists for their help. So he created this online platform called Galaxy Zoo. And with Galaxy Zoo, citizen scientists from all over the world could sign up and volunteer to help look through all these images for him. And it worked really great because thousands of volunteer citizen scientists ended up signing up and they were able to categorize all of those images in just a single month. So what would have taken that grad student 3 years took the power of citizen science only 3 months to do. And the other really great thing about using citizen science is not only were they able to get through all of those images very quickly, they were also more accurate than the grad student would have been if he had done it alone. Imagine how tired he must have been working 12 hours a day and looking through very similar images over and over and over. You can imagine that it probably would have been very easy for him to make a mistake. But with thousands of volunteer citizen scientists, each of those images were looked at 38 times by 38 different people. And so it led to more accurate information because they were essentially looking over each other's work as they went instead of an overtired, overworked grad student looking through all of these images by himself. So that kind of leads to what's now called the Zooniverse, and it's the world's largest online platform for citizen science. So Galaxy Zoo, that citizen science platform that grad student created, is actually still up and running today. This is an absolutely 100% true story. And since the inception of Galaxy Zoo, this platform called the Zooniverse has evolved, and it's become, again, one of the world's largest online platforms for citizen science. And so Galaxy Zoo is just one of over 350 projects on this platform now. And not all of these projects are in astronomy either. They have projects in astronomy, but they also have projects in zoology, ecology, the biomedical sciences. I saw a lot of people in the chat talking about anatomy and how they're really interested in that. So now there's over 2 million registered volunteer citizen scientists from all over the world that have signed up to help with all of these projects, and many of which are students in classrooms all over the world. Galaxy Zoo has volunteers as young as just 8 years old working and helping with all of these real scientific research projects. So Zooniverse is all about people-powered research, and this is just another fancy way of saying citizen science. So how it works is professional scientists, again, in all disciplines, astronomy, zoology, biomedical, they can post their collections of hundreds of thousands of images or videos, just like that grad student had with Galaxy Zoo, and they can post all that information on the Zooniverse. And then anyone, regardless of their background, their age, or their location, can answer a series of questions and help these scientists to start categorizing or processing all of their data. And it's turned out to be really, really effective. Because again, many people look at those same images, and then the researchers can synthesize and study their data much faster than if they're trying to do it all on their own. So how does Zooniverse work? Volunteers are able to sign up on the Zooniverse and they can classify and assess data by themselves. And then between 3 and 80 citizen scientist volunteers analyze each individual image or video file. And then all of those responses are combined until we get a consensus. So there's really no need to worry about making mistakes because you have a lot of people looking over the same image. So you have a lot of people checking your work. And then that data is made available to those professional scientists or the researchers, and then eventually they're available to the public as well. So volunteers are also able to interact with each other and with the researchers of the project. So if you're flipping through images and you see something that doesn't look quite right, or you have a question on it, you can actually talk to other people on the platform or to the scientists themselves to help figure it out. And I want to address something that I mentioned a little bit in that last slide, and that's what if I make a mistake? Because I know I hear from my students all the time that they're so worried about making a mistake when they're doing citizen science. And I hear them say things like, I don't want to submit a wrong answer. What if I mess up the research project? What if I don't know the right answer? Or I'm scared to start because I don't want to mess up. And that's really not a good idea to look at it because mistakes are a part of science, and they're a really important part of science. I love that someone put in the chat, if you make a mistake, people will correct you. They absolutely will. And that's what science is all about. It's about making mistakes, and then we can learn from them and we can learn to correct them. And also that's the great thing about citizen science is that there's so many people, again, looking at those same images. You have 3 to 80 people looking at each image of that data set. So if you make a mistake, the chances are is someone else won't be making the same mistake. And so someone else will check your work. And on top of all of that, the professional scientists will look over all of the responses from all of the citizen scientists and see what most of the volunteers agreed on. So you have a couple levels of check there. So I want to take a break here right now. Let me copy this link, and I'm going to put this link in the chat. And this link is to one of the projects on the Zooniverse, and it's called Penguin Watch. And I would love if y'all could open up this link that I just put in the chat, and it will take you to this website. Let me go back. So it will take you to this website right here. And with Penguin Watch, the scientists are asking the citizen scientists to identify penguins. So I thought that this would be a great opportunity for you guys to start and look at an image. So you can go to this link and click Rockhopper Fiesta, and you can start identifying penguins. So you'll just click on each penguin, and they ask you if you see chicks, eggs, or any other type of bird. So if you see a chick, you could click there. And if you make a mistake, you can X that out. This particular image has a ton of penguins. Most of them don't have this many birds on there. But you'll just go through and you'll mark all the birds. So go ahead and play with that a little bit and see if you can identify any of those birds. And as you do, and as you finish up, feel free to put in the chat, how many penguins did you see in that image? And did you see any chicks? Did you see any eggs? Or did you see any other birds? Because those are a little bit more rare to see. So I'll give you all a couple minutes to go through that. And if you have any questions, you can also drop those in the chat as well.
Quick question, Heather. What type of penguin is this?
These are rockhopper penguins. That's why it was called the Rockhopper Fiesta.
Oh, I see. And this one? Is this a rockhopper?
On the screen here.
Yeah.
Yeah, I believe these are all rockhopper
Oh,
penguins.
okay.
Mhm.
Okay, cool.
Yeah. And when you do have more time on your own, you're welcome to go in and there is more information and more instructions. Um, Let me put the link in the chat one more time in case anyone missed it. And this is one of the more simple projects. All you're doing is clicking on penguins to identify them so the scientists know where to look when they go back through them and about how many penguins are in the area. But again, there's tons of different projects you can work on. I chose this one just because we don't have a whole lot of time today, but there are projects that take a little bit more work. So once you're in the link, let me go back again. Once you're in the link, you'll scroll down and you'll click on Rockhopper Fiesta, this button right here. And that will bring you to the image. Yeah, I see comments about usually doing physics and space projects, maybe some information about the sun. And there are astronomy-based projects on this site too. Like Galaxy Zoo is still up. You can still go look at galaxies and help identify them. For the sake of time, I think I'm gonna stop here for now, but if you have questions while you're looking through um, the link, and I'll also provide the link again at the end, feel free to put those questions in the chat and I can try to address them after we're done chatting about all this. But if you've gone through and you've looked at one of these images and you got to identify your penguin, then congratulations, because you've just contributed to real scientific research. And as easy as that sounds, it's very true. So you're helping to locate penguins and kind of discover, you know, how many penguins might be in the area, and you can definitely go back on and learn some more about this project as well and see what other projects Zooniverse has to offer. But I'm going to change gears just a little bit and talk about Exoplanet Watch. So Exoplanet Watch is another citizen science group, and it's separate from the Zooniverse. It's part of the NASA Jet Propulsion Laboratory. Um, And before I start talking about Exoplanet Watch, I want to hear what you might know about exoplanets. So if you know anything about exoplanets, or if you've heard anything about exoplanets, or if you've had some questions about exoplanets, feel free to put those in the chat just to see where we're all kind of at. Yep,
Carl,
exoplanets.
yeah, Carl says exoplanets are planets outside the solar system.
That's perfect. Exo means out. Yep, outside of our solar system. And we'll talk a little bit more. Yes, there's super Saturns, and there's also hot Jupiters. Yeah, so it looks like we have a good idea in general what an exoplanet is, right? So it's an exoplanet outside of our solar system. And I just wanted to put this up here for just a second because exoplanets.nasa.gov is a great resource because there's a lot of questions in the chat today and I won't be able to get to them all. But this website kind of takes everything that we've learned about exoplanets so far and it puts them in one place. So, and I'll have this link again at the end of the presentation, but if there's any questions you have that I haven't gotten to, then you can go to this website and try to find some answers to your questions. But y'all were spot on about exoplanets are planets outside of our solar system. So they orbit stars other than our own sun. They have their own stars. And as an exoplanet orbits in front of its star, and it passes in front of its star, this is called a transit. So we can see this exoplanet transiting in front of its star. And as it transits, it actually blocks a tiny bit of that star's light. So you can see this little exoplanet is blocking a little bit of that star's light as it passes in front of it. And we can actually track that over time. So we can look at the brightness over time. And when this planet is not in front of its star, it has this constant brightness. And then when it goes in front of the star, the brightness is going to dip because that planet is blocking just a little bit. And as the planet leaves, the brightness will go back up. So we can track that brightness over time in what's called a light curve. And these light curves we can use for a lot of different things, and they're very informational. So they're very important. But exoplanets are kind of a new field in astronomy. The first exoplanet wasn't discovered until 1991. And I know that might sound like a really long time ago, but in the field of astronomy, that's quite young. So I have this little video that kind of shows how quickly we started discovering exoplanets over the years. So keep an eye on the year and the number of exoplanets discovered.
Wow.
So yeah, so it's really powerful when you put sound behind it, right? But so each of those dots were an exoplanet being discovered. And I don't know if anyone noticed, but right around 2014, we started to get a lot and a lot of exoplanets. And that's because we started to use that transit method and measure light curves as the planet passes in front of the star. We didn't need to take a direct image of it anymore. So the transit method really opened up a lot of opportunities. So there's a lot of different types of exoplanets. Someone in the chat mentioned a super Saturn, which is definitely a type. Today I'll be talking more about gas giants. So no rocky surface, you can't stand on them. They're just a bunch of gas. But more specifically, I'll talk about a type of gas giant, and they're called hot Jupiters. And hot Jupiters are very similar to the Jupiter in our own solar system that I'm sure a lot of you have learned about. So it's still very big and very gaseous. But the difference is that hot Jupiters are very, very close to their star. So they're even closer to their star than Mercury is to our own sun. And in fact, they're so close to their star that a year on a hot Jupiter is only 1 to 3 days. So that means that the planet is orbiting every few days. So it's going really fast. And as you can imagine, being so close to that star, it's very, very hot, hence the name Hot Jupiter. So the nice thing about hot Jupiters is that they're very, very easy to observe. Because they're so big and because they're so close to their star, they block a good amount of light. So we don't need big telescopes like the James Webb Space Telescope or large ground-based telescopes to observe them. In fact, hot Jupiters can be observed in your own backyard using your own telescope. People use telescopes as small as 4 to 6 inches to be able to observe hot Jupiters and to get a light curve from them. And so this opens the door for, again, citizen science, because we don't need access to really large telescopes to get light curves on hot Jupiters. So why do we need citizen science for hot Jupiters? It's really important that we continuously and frequently observe these hot Jupiters and keep their orbital parameters up to date, because we need to know when the exoplanet is going to transit, because that's when we will want to observe them. So other research projects might want more detail about the exoplanet, like what's in its atmosphere or something like that. And for that, they'll need to use those bigger telescopes. But in order to observe that exoplanet, they need to know when it transits. And using these big telescopes is really, really expensive. So we don't want to waste any of the time on those big telescopes just sitting there waiting for it to transit. So in order to not waste time, citizen scientists can help by observing these exoplanets with their small telescopes and making sure that they have the time that it's going to transit very, very accurate, so those big telescopes aren't wasting any of their time. So that's where Exoplanet Watch comes in. And again, it's a citizen science group, and we continuously collect data on hot Jupiters to keep that transit time very, very accurate. And that data is immediately public to the entire community and to the scientific community. And anyone who helps observe is actually going to be a co-author on these scientific papers that are published. So what do exoplanet watchers do? They collect data either with their own telescopes or with robotic telescopes if they don't have their own telescopes. They don't need them. And then they use provided computer programs to analyze the images and create those light curves that we were talking about. And then they share their findings with the scientific community so that projects using those big telescopes know when the planet's going to transit. And so far, this group has looked at over 400 exoplanets, and they've published almost 7,000 light curves, and we've saved almost 4 hours of space telescope time or large ground telescope time. So they're not sitting there waiting for the planet to transit anymore. We've saved 4 hours. And to put that in perspective, James Webb Space Telescope cost about $1 million an hour to use. So that's about $1 million or $4 million that we've saved so far, just by making sure that we know when these planets transit. So I think I'm all out of time today, but I know I went over quite a few different things today, so I wanted to put some links up. So I have a QR code to the NASA Exoplanet Watch website, a QR code to the Zooniverse website where you can go continue looking at penguins if you want, and then a link to that exoplanets.nasa.gov website if you want more information on exoplanets, if I missed any questions today. So thank you so much for listening.
Thank you, Heather. Fascinating. And that was really, really great. So Sophie, over to you.
All right, let me share my screen. Okay, hi everyone. So today I'm going to be talking about my experience as a citizen astronomer. So I know we already talked about this briefly, but I want to recap what a citizen astronomer is. So just whatever you remember the definition that Heather told you earlier, write that in the chat. So what do you think the definition is for a citizen astronomer?
Elisa says, a citizen astronomer is a public person contributing to real science.
Mm-hmm. Yes.
And Arlene says, a citizen who contributes to the research process.
Mm-hmm. Yeah,
Oh,
so
same
let me just share
idea.
with you guys. So let me just share with you guys the definition that I wrote myself. So I believe that a citizen astronomer is a member of the public, like you and me, who works with professional astronomers to carry out scientific missions and collect vital data that allows us to learn more about the universe. So now that we have talked a bit about this definition, I want to talk about how I got here. So my name is Sophie Saibi, as I said, and I am a citizen astronomer. Next year, I'm going to be a sophomore, so I'm going to be going into 10th grade. But my interest in astronomy actually began in 7th grade when I heard about the launch of the James Webb Telescope. And after that, my dad got a telescope called the Unistellar telescope. And this is a smart telescope, which means it's motorized and it's controlled from an app. So you can easily look at the pictures through a electronic device and control the telescope from there. And something really cool about this telescope is that they are in partnership with a company called SETI, a organization called SETI, and they collaborate together to create a citizen science program. And so before I talk about the citizen science program, I want to share with you guys a few of the pictures I was able to take with this telescope from my backyard. So this is the first one. This is one of the earlier pictures I took of the Pinwheel Galaxy, also known as Messier 101. And I just love this photo because you can see a lot of the different spirals. And if you look online, there's a lot of super bright and big details from huge telescopes that captured this galaxy. And when you compare that to this image, this one might not be as bright, but the fact that I was able to take this from my backyard is really amazing. And the fact that I was able to get an image pretty similar to those huge telescopes is also pretty cool. So next, I want to play a little game for the next two pictures. So here I have an image I captured of a galaxy, and I want you guys to guess the name of this galaxy. So there's a lot of different options that this could be, but just put in the chat and then I'll give you guys a hint after a while. Andromeda. Andromeda, when you actually take a photo of that, is much bigger in the telescope. Is it Saturn? Okay, let me give you guys a quick hint. So this is a picture of a type of hat. Does anyone know the name of this hat? Sombrero, someone said it, yes. This is the Sombrero Galaxy, and I like to remember it by using the hat because this is a Mexican hat, and the name of it is sombrero. And actually, you can see there's a little bit of similarity. There's like a thin side, and then there's a center that's kind of has a round shape. And so it's pretty cool. And then here's the next one for you guys to guess. This one's a little bit more abstract, but try and guess the name, and I'll give you guys a hint after a while. Someone guessed it right away. This is the Whale Galaxy. So this galaxy I think is really cool because you can see a bit more color in it. And the small blob on the side, I actually like to treat it as a whale pup and like a little whale's child. And so I think that's a really cool way to remember the name of this galaxy. Now, in addition to taking pictures of galaxies, I also took pictures of the moon. So I think it's really incredible that I can take these pictures and get really good quality of the craters and other textures of the moon, such as the Maria. And so in addition to all of these cool photos, I also am a part of a citizen science program. And that program is called NASA Unite. So the purpose of this program is to help us learn more about exoplanets with the help of people all around the world. And I have a video for you guys coming up from Raj Mathai from NBC News, Bay Area News, who explained the program very well. So let me explain it to you. Let me share that video.
Is there life out there in space? Amateur stargazers are helping NASA do the groundwork that could ultimately answer that question. And they're doing it with the SMART telescope in their backyards. The project is called Unite, and it's a collaboration between NASA, SETI, and a telescope company called Unistellar. The main goal of this program is to hunt for exoplanets. Those are planets that are orbiting other stars in our galaxy and have the right conditions to potentially foster life. Citizen astronomers are asked to set up their telescopes at a certain time, point them in a specific spot, and then upload the data. Is there life out?
Okay, so Raj Mathai explained this very well. And so basically, citizen astronomers will point their telescopes at exoplanets and then observe and collect data. So now I'm going to show you guys a quick video. Heather already talked about this a bit, but we citizen astronomers collect the data through exoplanet transits. So what you do is you measure the brightness, and that's the data that you collect from a planet as it orbits around its star. So you try and record the data, the brightness of the star, and then as the planet passes in front of it, the brightness of the star will decrease a little bit, and from that you can get a lot of cool information. So next, I just wanted to show you guys a quick video of a exoplanet transit mission called TOI 4600C. And I just wanted to show you guys how people all around the world are literally all around the world are observing these exoplanet transits, because exoplanet transits can take a long time to occur. So you need people to collect data all the time to piece together the information properly. So here's a quick video, and there were observations for this exoplanet transit from Japan, Russia, France, Finland, and the United States. So that's a lot of different countries, and it's really cool how people can all work together. So yeah. Next, I want to talk a bit about the process of the NASA Unite program. So what you do for each mission. The first step is NASA's satellite locates possible exoplanet candidates, and the satellite's name is TESS. And then citizen scientists all around the world record the exoplanet transit, and they record the brightness of the star. And finally, the data is uploaded and compiled into a graph. So as you can see in the bottom right corner, this is an example of the graph that you can see when you compile all the information. And if you look past those vertical gray lines, you'll see a red line with a small dip in the middle, similar to the video we saw earlier. And this is the kind of information that you get from those exoplanet transits. And it's information that's then given to scientists and researchers who can use it to continue their research. So now I want to talk a bit about why this is so important. So first and foremost, just on the spot, you can learn a lot from these exoplanet transits. So this data can tell us about some orbit characteristics, including the planet's orbit time and the planet's distance from the star, as well as its size. And these exoplanet transit data is also very important for the future, because with the information we get from observing on Earth, we can use that to accurately predict when the next transit will occur and have huge telescopes like the James Webb telescope point at those exoplanet transits and give us some more data. And some of the data this can give us includes more information about our atmosphere and about the exoplanet's atmosphere. And if we learn more about these exoplanets' atmosphere, we can see what elements they may contain and if they have a possibility for hosting life. So, join the fun. This is, as I said, a citizen astronomer program. So that means people, members of the public like you and me, can all join and are all encouraged to join and learn more about science. And just taking a step back from the citizen astronomer program, I just encourage you all to continue pursuing your interests in science and astronomy because it really is an amazing field and I love to learn so much about it.
Of all the discoveries and things you've done so far, what would you say has been your favorite or most interesting?
Well, I really like observing the exoplanets, but I'd say galaxies are still my favorite thing to observe. I just really like the different forms that they come in, the different shapes, and I like learning a lot about their history, like how they were formed and the cool things that happen within them.
Fantastic. So I think, yeah, we'll open it up for questions. We've got a few hands up here. Kemet, would you like to ask your question? You can go ahead and unmute.
Yeah, so while we're waiting, so for those of you that if you have a question, you can raise your hand and then we'll be able to see it. When we say raise your hand, don't put your hand in front of the camera. There is a tool that, yeah, you see Lily was able to raise her hand. Okay, Jax were able to raise her hand. There is a reaction tool in there. If you do, then it actually see the little hand. And then when Bruce calls your name and he's going to unmute you and then you can start talking. Go ahead, Bruce.
Okay, great. Kemet, you can unmute, please, Kemet.
Yeah, actually, let's move on to Lily. I think Kemet might have his hand raised for
Okay,
a bit of time.
sure. Lily, do you have a question? Okay, we lost Lily.
I'm
Yeah.
sorry, I unmuted her. Just see. I'm gonna unmute Lily now.
Okay.
Go ahead, Lily. Can you say let me see if I can unmute her.
What colors can they be?
Can you ask it again? Sorry.
What colors can they be?
What colors can they be?
Yeah. What
As a
colors
girl-
can galaxy be?
Heather and Sophie, you guys can feel free to jump in and either one of you can answer it. Go ahead.
Sophie, you can go ahead. You've been talking about galaxies.
Okay. Well, galaxies, from the images that I've seen, it's mostly based on what kind of filter you put on or what kind of tools you use to enhance the galaxy. But usually, like I showed in the Pinwheel Galaxy, it's kind of a grayish color on my telescope or the blue color like the Whale Galaxy. And the Sombrero Galaxy is actually a pretty rare case from what I've observed where it's kind of purplish. But there's a lot of really cool colors. Yeah.
Thank you for answering my question.
Awesome. Let's go to Carl. Go ahead, Carl.
So if there are billions of planets in the galaxy and there's a low but possible chance there's life on an exoplanet, shouldn't there be like a bunch of planets that have life on them?
Yeah, so That's really interesting to think about because there's not just exoplanets in our galaxy, there's also millions and millions of other galaxies. And we consider our universe to be infinite, so there's no end to our universe. So really, there's an infinite number of other planets that should have life on them. And right now, we're just working up the technology to be able to discover that. So Sophie was talking earlier about studying the atmospheres of exoplanets and what molecules might be there. So that's some work that I've done with hot Jupiters, which we don't really expect life to be on because they're too hot and they're too full of gas. But we're working on those techniques on hot Jupiters so that we can look at other planets that might be more similar to Earth, close enough to their star that it has liquid water on it, but not too far. And we can start observing those atmospheres and hopefully find life not too far away from where we're at now. We don't have that much further to go in terms of technology, so hopefully we'll find that soon. Yeah, the Goldilocks zone, exactly.
Mhm. Excellent. Let's go to Jax. Go ahead, Jax.
How like are exoplanets bigger than dwarf planets?
They can be. There's also exo-dwarf planets. So there's dwarf planets that go around other stars. Exoplanets come in all shapes and sizes, just like planets in our own solar system. So some of them are much bigger. Hot Jupiters are much bigger than dwarf planets, but there's also exoplanets even smaller than dwarf planets as well.
Oh, very good. And Ishan. Go ahead, Ishan. Ishan, do you have a question? Hmm.
You need to ask to unmute them.
Oh, okay. Yeah.
Go ahead,
Go
Ishan.
ahead, Ishan.
You want to try to speak again, Ishan? I want to move on to the next person first.
Okay, let's try Zara. Go ahead, Zara. Hmm.
Hi. Could you tell me more about a research scientist's responsibilities?
Yeah, so I can tell you about like a professional research scientist, and then I'll let Sophie tell you more about being a citizen scientist. So for me, I'm lucky enough, I feel like I have the dream job. I get paid to do research. So I do it every day. I usually work from 9 to 5 every day, probably like a lot of your parents. And a lot of times I'm on my computer. I also mentor college students and I teach them how to do research as well. So I have to handle doing my own research and then teaching others how to do research. And then I also love to do things like this where I communicate with other people and teach them about the type of research that I'm doing. Because what's the point if you don't get to share all the cool stuff you're learning?
Excellent. Okay, great. Rehana. Go ahead, Rehana. But you were unmuted.
So when we call your name, where you're gonna see something on the screen says unmute, and then you should unmute yourself. Like,
If exoplanets are are small and big, how big can they go? Like how big can they be?
They can be really, really big. We talk about hot Jupiters. those are some of the bigger exoplanets, and they're the same size as Jupiter in our solar system. So I don't know off the top of my head, Sophie, I don't know if you know like a ratio, but Jupiter is much, much bigger than Earth. I want to say off the top of my head that something like 300 Earths can fit in the size of Jupiter. I can look it up real quick. But they can get really big, much bigger than the planet that we live on.
Good. Anything you'd like to add to that, Sophie?
Yeah, so actually I was doing a bit of like learning about exoplanets earlier, and in terms of Jupiter masses, some can reach up to 10 or 100 times the mass of Jupiter. I have a graph and it shows that, which is pretty amazing.
Wow. Okay, let's go to Jason. Jason.
Hi.
I'm sorry. Go ahead, unmute yourself again, Jason.
I have a question. So I'm wondering, are there any exoplanet in the Goldilocks zone, or also known as the habitable zone? Hello?
Sophie, I've been talking a lot. Do you want to answer this one?
You can go ahead. I don't know that many
Okay.
different.
Yeah, so there are exoplanets in the Goldilocks or the habitable zone. In fact, there's a lot, and the James Webb Space Telescope, or JWST, has been helping us find a lot of those planets, and we're hoping to start looking more into the atmospheres of those planets and see if they might have life on them. So the science is coming out more and more every day, so fingers crossed that one day soon we might be able to find a planet that can hold life on it.
I have another question. So is there a end to space?
That's a really great question, and it's a very big question. So there is an end to the space that we can see because our universe expands. And so the further that you look away from us, the further that Earth or that space is expanding away. And eventually you'll be able to look so far away that space is actually expanding away from us faster than the speed of light. So we can't see anything past that. And that's called our observable universe, which is 13.6 billion light years. So that's a whole lot. But space still exists past the observable universe. We just can't see it anymore. So it really doesn't have an end. It just keeps going forever.
It's fascinating.
Great.
We're going to do two more and then we're going to wrap this up. Okay, go ahead, Bruce.
Okay, we had one in the chat. It was an interesting commentary just to see what you guys, Sophie and Heather, think. Life on other planets fills me with both shivers and excitation or excitement. I'm not so sure about the shivers. So I think what I get from that is like, should we be worried, or should we be welcoming our alien friends with open arms, sort of like Carl Sagan, I thought was a good idea with the Voyager spacecraft.
I can go first. I'm not scared of finding other life. I think that it's very exciting. The chance, and remember when we're talking about life, we're talking about all kinds of life. So, we'll probably end up finding, little bacteria on other planets. We're not really talking about finding other intelligent life, like other people on other planets. That might take a lot longer to find. So the idea doesn't really scare me. And I think that we've known forever that there has to be other life out there. And so I think that it would just be an amazing accomplishment to finally have proof for that and be able to find it. So I'm just excited for it. But Sophie, do you want to share what your ideas are?
Yeah, I mean, I think that the idea of a habitable exoplanet is really cool. And I think that, I mean, knowing that there's another planet like that out there to me would be really amazing. Yeah.
Okay, one more. Let's go with EDT. EDT, please.
Yeah, keep muting me. But either way, my question is, I know there's a lot of other questions that a lot of people would ask, but the one I want to know about most is how many like dwarf planets exist in our galaxy. There might like be hundreds or thousands.
So dwarf planets, at least dwarf exoplanets around other stars, are going to be very hard to find because they're very small and they're so far from their star that not a lot of light is being shed on them, and they don't block a lot of light when they transit their star, so they're hard to find with those light curves. But we have I think that we recognize 5 official dwarf planets in our own solar system. So we can assume, we know that our sun is nothing special. It's just like almost every other single star in our galaxy. And, our solar system is nothing special. So we can expect to find a similar number in each of those solar systems. So for all of the millions of stars in our galaxies, we can expect around 5 dwarf planets for each of those stars. So millions and millions of dwarf planets in the galaxy.
All right, great. Well,
Cool.
thank you. I think we're going to end it there. Thank you so much, Heather and Sophie, for your excellent talk. I learned so much myself as well. And it's pretty amazing that how much many of our students know already and really asking all the excellent questions. So thank you for sharing. Definitely everyone, summer probably, for some of you probably ending in a couple of weeks. And for some of you might have a month to go and join our summer camps, and it will be pretty exciting to learn more, whether it's about NASA, space science,